Hello everybody, this video is about data wrangling. In this tutorial, I will show you how to work with real-world data we downloaded from a public dataset as a CSV file. The data for this tutorial is provided from the Los Angeles Police Department. It contains crime reports from 2020 until 2024 and can be downloaded at this URL. This is where I got the file. When you search the database, then you find a topic you like, you click it, and then you have a choice of what file format you want. And I took the comma separated values file, which is a CSV file. If you go to the home button, you see how the whole data bank looks like. It's from the government. That's why it's free. And you can trust this data. It's from data.gov, and you can browse what's around and then pick a topic and download that CSV file. I saved the file in the same folder as this Jupyter notebook. That makes it easy to load the file into a data frame. We then load it into a data frame and start exploring the data. Most likely, you're not interested in all the columns, but other data you're interested in is missing. One of the first steps is to clean the data set and creating a new data frame with data we will be investigating further. These are the first steps you do after downloading the file as a CSV file. Creating a data frame with all the data from the original CSV file, composing a new data frame using only columns with data we are interested in, transform time data into Python's datetime format, creating new columns for data we derive from the existing original data, and then the next step is to create a simple line graph to get an overview of the data. These are the functions and methods we will be using in this tutorial. We use the pandas functions read CSV. We also use pandas data frame methods, rename, drop, group by, to datetime, datetime index, sort values, is in. And we also use the Seaborn function line plot. We start with the import block of the tools and libraries we need. We need pandas for the analysis and working with the data frames. And for plotting, we have matplotlib and Seaborn. This one is optional, this line, but it helps reading the entries in the column of our data frame, because by default it's kind of thin or narrow. We can't read the full entries. When we set the column width wider with this option, we can read the whole entry of the data frame. Okay, we start. That's the first bullet point here. Store the data in a data frame. So we name it DF, and this is how we read the file and store it as a data frame. To see if that worked, what we did, we have to display the data frame to just make sure it worked and we can continue. So we execute, and this is how it looks like. So it's a pretty big data frame with, we see here, more than 1 million rows and a lot of columns. And that's what I meant for we create a new data frame with only a selection of the columns with data we are interested in. So we pick date occurred, and we also pick crime description. It's this column. Go back. And here we see it's vehicle stolen, burglary from vehicle, bike stolen, and so on. And this is what the police officer wrote down in their database when the person reported a crime. And the rest we don't care about for our analysis. So let's create our new data frame we want to work with. We call it, so we don't want to display this anymore. We create our new one. We call it crimes. And this is how we create a selection of it. So we create a brand new one with this command df by looking up the columns. We list the columns we want to look up, and then create a new one we call df crimes. So I'm going to use the mouse to copy and paste the names crimes, and we also look up date occurred. We look that up, and to create a new data frame, we need another square bracket here. Because that's our list of columns. Bracket closed, and we want to make sure we have a proper copy of this data by adding this copy method. Okay, we test again if that worked. Display our new data frame, df crimes, and we execute this. Okay, this is what we wanted. Only the columns we picked, and they are all listed. Just each crime has its own line here. So we need to do further data wrangling to make sense of it and to use it, because that's why we have 1 million lines. Each crime, someone walked in, the policeman wrote it down and put it in the computer. So the first steps are we rename columns so that they make more sense to us. So we call this one, I would call type of crime. And then we will also change the date occurred column. This is the format we found in this database. This is imported all as strings. We want to convert this date here into a datetime format from Python. Okay, let's do the next steps where we clean it up a little bit more. So we say df crimes, we create a new column, we call it date, and now we define the new column. Since this date column isn't part of this data frame yet, it will just add a new column, date, and this is how we do this with the datetime method. So I just copy and paste here the whole command. So pd to datetime, here's where we look up the data in our data frame df crimes, the date occurred, because that's what we have right now. It is in this format, day, month, year. Oh no, month, day, year, and then the time, hours, minutes, seconds, and then AM or PM. That's why we have all this here. That's the current format. But with this to datetime, we convert this to the datetime format. And let's check it, how that changed our data frame. We run this again. This is our previous data frame, and now this is the new one. So it got the new column. And then instead of this date entry, it became this. Okay, so now we don't need to show this anymore. That was just for now to compare and see how that works. We also don't need this anymore. The next thing is, So here's already date. So I want to rename this and I want to drop this. Now that we have added the new date column, we can delete the date occurred column. We do this with the drop method. So we define our new, or the crimes data frame by taking our crimes data frame and adding the drop method. And we have to say which column we drop. It's this, we don't need anymore. And we need the parameter axis equal 1 for column. Let's double check. Display df crimes and execute it. Now let's rename this column name here to give it a better name. Instead of crime description, let's just call this column type of crime. So we use the rename method. So we pull up the data frame, df crimes, and rename. We want to rename the columns. And we pick that column name here. And this becomes type of crimes. And we need one more parameter to actually rename it inside that data frame. It's in place. True. To test it, we need to display it also. Display df crimes. We run it. Okay, this is what we want. Type of crimes and date. And we solve the problem that each crime gets its own line here. So to do some analysis, we need to bundle this and group it by years, for example, or by type of crimes. Okay, now let's add a column of year to be able to later sort them, the crimes by year. So let's add a column to the crimes data frame, crimes. And this is how you do it, just a square bracket, crimes. If this column doesn't exist, it just makes a new one. And now let's define this. And this is where our date time index method comes in. And this is what I want to enter here. So we look up the pandas, the methods, the date time index. Here's our data frame crimes. We look from that date and we will get the year out of it. So instead of having the whole date, it will only tell us the year for each thing. We'll still keep the old date, but this is just an additional column in the data frame. Let's just check it out. And so we added another column, just year. So now we can do some analysis. Let's look up how many crimes did happen each year. So right now, each crime has its own line and it's listed in the year. So now we need to use the group by method to group it by years. And then we need to look up how many items do we have in each group. So we'll look up the df crimes. We need to define a new data frame, new as crimes count equal our DF crimes, and now group by, and let's say by this variable here, year. Year, as we know how this group by works, if we do this one will not be helpful. We need to add another attribute to it. So we want to know the size of each group. And the size, and we need to reset the index to give the count variable a name equal count. And now let's display it to check it out. Display DF crimes count. Okay, so we have 4 groups because, or 5 groups because we have 5 years. Each year has its own group, and this is how many entries each group has. So it's 199,000, 209,000, 230,000, and so on counts. So we, instead of years, we can also say, okay, let's see. So we replace the year with a type of crime. Let's take this type of crime. We copy this and paste it over the year. And now let's display this group. So now we have it sorted by type of crimes. And I guess that it's a standardized kind of labels, how the police labels the type. So there's only 140 different labels for the crime. And here are the counts for each label. And it's sorted by the type of crime. So it starts with A, arson, assault, and goes all the way to weapons, possession. If we want to sort it by the counts, which would be more interesting for us, so what are the most common crimes? We have to sort our data frame by the variable count. So we say df count equal sort values method count one, and so that we don't start with small numbers and go up, we need to say set the ascending parameter to false. So now we have it sorted, the highest number first. So most crimes are vehicle stolen. And if we want to see more than if we only know the 5 most common crimes, so if you want to know more, we have to add the head method, because 5 is the default. Let's say we want to see the 15 most common crimes. Display this one now, and now we have the 15 most common crimes. So it goes up, highest 5, same, and then it continues if we want to make a statistics with the crimes. So now we can already work with this and see and graph it. But okay, now it's just all 5 years together in one count. Let's group it also according to, like here's our line 16, where we grouped it by types of crimes. Let's also count it by years as well. So then we need the square brackets, type of crimes, because we give it a whole list, And then the other variable is year. So now we group it into the two things together, group it, and then we display our next table. So that's why this is now looking into each group depending on type of crime and year, and then that number, and this is still sorted by count. So now we have seen the most common crimes here, and we might want to just create a new data frame with the most common crimes so that we have just a smaller data frame to work with and to cut the ones which rarely occur. Crimes, common. We define this, but also before we define this, let's just make a list of common crimes. Crimes equal. Now we've, from our previous tables and data frames we printed, we have an idea which ones are the most common ones. So now we just list them all up. The most common crimes we list here. So I've done this before in a separate file, so that I have to retype everything. So copy, paste all the common crimes. So that's our list. And now we create our new data frame with the common crimes is equal data frame crimes count. So we take that, but now we make a condition that when we look up that data frame count, type of crime, type of crime, and then the is in method crimes. That's why I created that list here. If what we look up here is in that list, then it gets added to the new data frame, which we call data frame crimes common. Let's check it. Display df crimes common. And we might, let's take this out to display a little bit less. Okay, so these are now the most common crimes. Now, next step is, let's focus just on one year, year 23. DF crimes 2023, another definition, equal DF crimes common so we look it up, square bracket, DF crimes common the year value when that is equal to 2023. We also check it. We don't want to display this anymore. We display the latest data frame we made, DF crimes 2023. Run. Okay, so now that's why no surprise, all the list is only 23. So it would still show it, we still left it in the data frame. And these are the most common, the ones from that list only. And then sorted by the occurrence, by the count. So let's do another analysis by just showing the different crimes which happen in different years. And so we have to define a figure, object, figure, equal, and that's why we needed to import Seaborn. So line plot, and then we have to define what are the x values. X equal here, y equal the count variable, and the data is equal. Now we have to pick which data frame we use. So now actually I don't want to look at this data frame with only 23. I want to look at all years. What do we have? So I take the whole one, but only the most common one. So I take this data frame common. So it has all years, not just the from 23. I copy that. Data is this data frame. And the nice thing why I use Seaborn, it has the U parameter to differentiate between the different sections we got. And here we can use another column to have several lines separated by the type of crime. Okay, let's plot this. So let's delete this display and plot this first figure. So there's the line, or it looks kind of ugly. We still have to tweak it and make it nicer to get an idea what happened to the crimes. So one thing I like to do is to push the legend to the side. And then typically I have the PLT show method, but it did show it also without that. So, but this is just a little bit cleaner, then you know what happens. So with this command here, the legend method, I could change the default legend because it's in the middle. It also has very long labels. So now it's just pushed to the side in order to see the image better. So there it is.